Hello, in this video I will share a few tips and guidelines on how to write a good IA in the scientific subjects such as chemistry and physics. I'll give the structure that I used, but of course you might have to change it to fit your IA. I will also go through the assessment criteria and give tips on fulfilling the criteria so you can achieve as close to maximum points as you can. So the structure that I used was the introduction, and this way you introduce a topic, and then the objective of the IA, that's where you introduce your research question. And then I went on to background information, or what I call the assumptions that I made. And then you have to go into variables, where you state the independent, dependent, and controlled variables. And then you go on to the equipment, where you provide a diagram of the equipment you used. You should use a software such as eDraw. You can find a software on the internet to make use that instead of Paint to make it look more professional. And then you also have to state your method. It has to be written in past tense and numbered. You should also state why you did this and look at a different method that you could use, but state why you took your method and not the other method. And then go into data collection, which is where you present your measurements and the raw data and your observations. And then on to data analysis, where you use graphs, diagrams, calculation figures, etc. to show and analyze the data you collected. And you have to comment on the graphs, what they mean, etc. I'll talk about this later. And I'm going to go through the assessment criteria. And then it's a conclusion, and this is where you answer your research question based on the data analysis and variables and assumptions made, the background information. And then it's the evaluation, where you basically evaluate and go into further detail later. And then you have the bibliography, where you have to give credit for, if you got information from a book, you have to give credit to the author. Personal engagement is the first criteria, and this is where you justify and explain why you picked the topic. Show that you're curious about the topic by maybe putting in a short story explaining your interest in the topic. You also have to show personal input and independent thinking, so you would have to make your own diagrams of the data and use your own interpretation of the data for your analysis.
Exploration. This is the section where you introduce the research question and the topic. The research question has to be focused and specific. For example, how does the anodization of aluminium affect the corrosion resistance of the aluminium sample? Is a better research question than how does electrical chemical processes affect physical properties of aluminium? Because the first one is specific about which physical property and which electrical chemical process, while the second one is general.
Analysis is the third criteria, and this is where you have to include a good amount of raw quantitative and qualitative data that can be analyzed and later referred to in your conclusion. It should be detailed and relevant enough to support your conclusion. You need to show process data and present this. This is the analysis of your raw data that you have calculated. Look for patterns, correlations, proportions, etc. and look at how your variables affected the results, and then plot the results into a graph and also represent your data in the diagram. Then you would have to state the significance of uncertainty in measurements and say how it would affect the results. Evaluation is the fourth criteria, and this is the part where you show self-awareness, something that IB really likes. You should be able to look at what you did well and what you didn't do so well, so you could improve and tell what you could improve on to make the investigation better. You need a detailed conclusion that is explicitly answering your research question, and you should also refer back to your data collection and data analysis in your conclusion, or answer if you want to call it that. Look at the accepted scientific information or data and compare results to in the accepted scientific context. If it doesn't agree, mention why it might not agree. Maybe it was something different you did in an experiment compared to the experiment a scientist did, and mention how the difference could affect the data. State the strengths and weaknesses of your investigation. This could be limitations in materials for experiment, limitation of data / experiment, errors, and so on. This should be thoroughly discussed and refer to the part in the exploration about methodology. Explain your method and provide evidence of why certain things were limitations. If you didn't have access to a material for your experiment and had to use something else, it might have affected the results, so mention this. Discuss improvements on methodology and investigations to reduce any significant errors and limitations. Suggestions for extensions should be also included, because they show that you're interested in the topic, that you learn something beyond your syllabus. Communication is the final criteria, and this is about how you present your investigation or your internal assessment. The report has to be well structured and in a logical way, so it has to have a strict structure that you follow. Information is focused on what is relevant to the internal assessment, and it's presented clearly, so it reflects good understanding of the subject. Subject terminology needs to be correct and appropriate. There's no need to try being fancy with the terminology and being incorrect. It's better to be so make sure you're using the terminology correct. Check up on the definitions in your book if you're uncertain. You should follow formal conventions for your internal assessments. For graphs, tables, diagrams, they all should be labeled. Graphs should have axes that are named and should all have titles and explanation. There should also be correct use of units that follow the SI unit system and the number of decimals and significant figures. Citation and references should be consistent with the type or the style. Of course, type and style might depend on the teacher, but it should follow the academic honesty section on the subject guide that is available on the internet. Footnotes can be used to explain unusual things such as terms and definitions. Ask your teacher to go through student examples for internal assessments in class, so everyone can look through together what the student did well and didn't do well, so you don't make the same mistakes, and you can also do or take inspiration from the student. Also look at comments made by the examiner to look at what IB likes and what they don't like in terms of format and structure.